Why does a massive ship float, but a tiny pebble will sink? And the answer is simple. It's all about upthrust, and I'm going to show you exactly what that looks like in this example that we'll do. So we have a boat of mass 500 kilograms and it displaces 150 meters cube of water when it is lowered into the river. So relatively weighty boat, we'll say. And we have the density of water, and as usual it's around 1000 kilo per meters cube. So what we need to determine here is whether the boat will float and the upthrust acting on the hull. This is going to be quite a lovely question, so just stick around until the end and you will understand exactly what the calculation entails. So we have the mass of the boat. We know that the mass, so let's just say MB, which represents the mass of the boat. Let's say that's 500 kilogram, as that's what we're given in the question there. We know what the density of the water is, so I'm just setting out my stall now. So water, W, and that's the density, which is 1000 kg per meters cube. So that's the density of the water. Now, what we have here is also the volume of the displaced water. So V for volume and W for displaced water. So that was 150 meters cube. And that's everything. So that's all we have to use here now to figure out whether or not this boat will float or if it's gonna sink. So what we're going to start off with, since we already know what the mass of the boat is, we can actually calculate its weight. So we're going to convert the mass of the boat into weight. And how we do that? So let me just write this out. So this is the weight of boat. So how we're going to do that is going to be quite simple. If you know what the mass is, which is 500 kilograms, and you know what gravity is, then you know what its weight is. So we're just going to multiply that by gravity and we end up getting its weight. So its weight here is going to be 4.91, and I'll write that as kilonewtons. So the weight, you'll notice here, because of the unit I'm using, you notice that this is actually a form of force. And this is going to be something that we come back to. So we're going to figure out now what the weight of the water is, because we're going to have to do some comparison. So let's get into that bit. Let's figure out what the weight of the water that's displaced is. So we know that density, so that's a symbol for density, is equal to mass divided by volume. And because we know the volume of the displaced water, we know the density of the displaced water, we're going to just rearrange this to get density multiplied by volume. So the volume was 150 meters cube. We know density is 1000. So then the mass here is just going to be 150,000. So I'm just going to write 150 times 10 to the 3 kilogram. And once again, if you know what the mass is, then you can work out the weight. And remember, the weight is a form of force. So we're going to look at the weight of water displaced. And to do that, so W for weight of water, we're just going to do the same thing. We're going to do 150 times 10 to the 3 multiplied by gravity, and we get that final answer here as 1.47. And this is actually a big one, so this is mega newton. So that's the weight of the displaced water. Now, how is it that we're going to determine whether or not the boat will float or it will sink? All we need to do here is to compare the two weights. So if the weight of the boat is actually more than the weight of the displaced water, then the boat is going to sink. But if the weight of the displaced water is more than the weight of the boat, then the boat will float. And in this case, 1.47 mega newtons is 1.47 times 10 to the power of 6. And that's the weight of the water displaced there versus the weight of the boat, which is 4.91 times 10 to the power of 3. So the weight of the boat is significantly lesser than the weight of the water displaced. So luckily for us, this boat will actually float. Now, if you like this video, just give it a thumbs up and subscribe to the channel for a lot more engineering and maths content.